to another example to design a PDA. So, design PDA for the language L is equal to W such that the number of A's in the string W should be equal to number of B's in the string W such that n greater than equal to 0, and show the sequence of moves made by the string A, B, A, B. So, this is what the question looks like. We need to have equal number of A's and equal number of B's, but the order here is not mentioned. So, you can start with B and accept one A. So, you can have strings like this BA, BA, or you can have strings like this AB, 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 or you can have strings like AA, B, A, BB. So, something like this. So, there is no order for accepting the strings. So, you can have strings like B, A, B. So, you should still accept this kind of strings. So, this kind of strings has to be accepted by the PDA. So, how to design the PDA for this kind of strings? We will just take a look at it. So, again we will start from the initial state Q naught. So, we will start from the initial state Q naught. So, this is the string AB, AB, and we will see how the stack works. So, if you write down this, you will understand how to design the PDA for that string. So, when you are reading A, what happens? Z naught is in the stack, you will just push it into the stack. When you read B, so when you are reading B and A is in the stack, so you should see here, there is a opposite element, opposite string. So, when you are reading A, you pushed it into the stack because stack was empty. Now, when you are reading B, you already have one A in the or A in the stack. So, what will you do? You will simply pop it. So, when you are receiving B and you have A in the stack, you will pop it. So, next you are receiving A and A Z naught is the top stack element, you will simply push it into the stack, and then when you receive B, you will pop this. And when you reach end of the string, you should have Z naught as the top stack element. Then you can accept this kind of strings using the PDA. So, similarly, what if the string starts with BA, BA? So, if it is string which is starting with B, then your stack will be empty, Z naught. So, B you are reading a B element and top stack element is Z naught. You will simply push it into the stack. And A is the next input symbol which you are reading, and the opposite symbol is already in the stack. So, what will you do? You will pop it. Again you are reading B, Z naught is a top stack element, you will simply push B to the stack. Again you are reading A, you will pop this out. And when you reach epsilon, stack element should be Z naught, you need to accept that string. So, we will see one more example wherein you have a string called BBEE. So, even this can be accepted by the PDA, right? So, if you get such kind of a string, what will you do? Again you have the stack element Z naught. When you read the input symbol B, you will simply push it into the stack. Now, again you are reading B and B is only in the stack. Then you need to again push that into the stack. I am telling you, if there is a same element, your input element is also B and stack element is also B, then you will just push it into the stack. And the next A, so you are seeing the input symbol is A and B is the top stack element, again opposite, you will start popping it. Again one more A, you will pop this, so you will reach the epsilon and Z naught is the top stack element. So if it is same elements in the stack as well as the input symbol, then push it. If it is different symbols, then pop it. So that is how you have to design the PDF for this. So you need to know what kind of strings will be accepted by this language and how to design the PDF for it. So we will start designing, because we have seen several examples how which kind of strings comes in this language. So for that we will design the PDA. So as I said, your first element can be A or B. So your first input symbol can be A or B. So we will stay in the state Q0. We will stay in the state Q0, and you are accepting A and top stack element is Z0. What will you do? You will simply push it into the stack. So A, Z0. So when you are reading A and Z0 is the top stack element, you will simply push that into the stack. One more example we saw that, in one more example we saw that your first input symbol also can be B. Then if it is B, you will have Z0 as the stack element. So we will push that also into the stack in the same state. Why are we staying in the same state? Because we do not know the order of A's and B's. In the previous example what we have seen, we had first all A's, then only we used to receive B's. But here there is no such condition. So you can have A and B in any order, so you need to stay in the same state. You need to stay in the same state. So B, Z0, you will simply push that into the stack. So B is the first input symbol, Z0 is the stack symbol, then you will just push it into the stack, B, Z0. So one more condition here. So when you read B and B is in the stack and B is in the stack. So we will see one more example. So if it is string like this, AA, BB, even this has to be accepted. So what are you doing? You are receiving A, your input symbol is A, which you have already pushed into the stack using this transition. One more input symbol is A. What is there in the stack? A. So A is the input symbol. You can have either A in the stack or B in the stack, like we saw AB string or BA string. So B is in the stack here, B is in the stack, and here in this condition A is in the stack. So we can see there are two conditions. You are reading A is the input symbol, but either you can have A in the stack or B in the stack corresponding to these examples. So if that is the case, what will you do? A means same symbol. If it is same input symbol and same stack symbol, you need to push that into the stack. So you will push AA as the push operation. And then if it is a different symbol, your B is in the stack and A you are reading as the input symbol, what do? You pop this out, as we have seen examples. So you will simply write pop. A comma B epsilon. Next you have B as the input symbol, and you can either have A as the stack element or B as the stack element. So this is again important. B is the input symbol. Either you can see A as the stack symbol or B as the stack symbol. What will you do? B, A, different, so just pop it. B, B, same symbols, so just push it as we have seen in the examples. So this will work for this particular string. So BA, again you are reading B and Z0, the very first transition, you have just push B to the stack. You are reading A, pop this out. You are reading B, pop this out. So you are reading A, pop this B out, and what do? You have reached epsilon, the last element of the string. So when you reach the end of the string, so epsilon Z0 is the stack symbol. Z0 should be there in the stack symbol. No A's or no B's should be there in the stack symbol, because equal number of A, equal number of B. For corresponding one A, for that corresponding B will be popped out. So by the end of the string, you should have Z0 as the top stack element. What do you do? Accept it by final state. So keep the stack as it is and reach final state Q1. So this is how you write the PDA for accepting number of A's should be equal to number of B's in the string W. So how to write the transition function for this? So we will just write the transition function for the same PDA. So delta Q0 is the current state. What do? You read A as the input symbol and Z0 is the stack symbol. You simply stay in state Q0 and perform a push operation A Z0. So this is what we have written. So next, delta Q0, B is the input symbol, Z0 is the stack element, Q0 B Z0. So this is what we have written. So next we will write the transition function for this one. So delta, again you are in the state Q0, A is the input symbol, A is the top stack element. So Q0 A, you will be pushing it into the stack. Delta Q0, for this A is the input symbol, B is the stack element. What do? You stay in the same state and perform epsilon, that is the pop element, pop that element. So delta Q0, for this B is the input symbol, A is the top stack element, so Q0 pop it. So for the next transition, B is the input symbol, B is the stack element, you will simply push that into the stack. So as already told you, if there is same elements, input symbol is also same and stack element is also same, you will simply push it. So BB, you will simply push it. But if it is a different element, AB or BA, you will simply pop it. By looking at this, you can understand. So this is how you design the PDA for accepting equal number of A's and equal number of B's in the string W. So we'll see the instantaneous description for AB, AB. So we'll write the ID for the string AB, AB. So we have already seen how to write the instantaneous description for the given string. So we will see Q0 is the start state. So what is the input string we are reading? AB, 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 AB is the input string. And what is the top stack element? Initially the stack will contain Z0 as the top stack element. So when you are reading A upon Q0 and Z0 is the input symbol, you perform this particular transition. So you stay in the same state Q0 and A will be pushed into the stack. The remaining string would be BAB, BAB and EA Z0. So we'll push A to the stack. Next, B is the input symbol, A is on the stack, Q0 is the current state. So what do? You perform this operation, you perform a pop operation because opposite symbols B and A. So we'll write the transition. You stay in the same state Q0. The remaining string is AB and you pop it from the stack. Again, Q0 is the current state, A is the input symbol and Z0. You again perform this particular operation. So you stay in the same state Q0, remaining string is B, A, Z0. You push A to the stack. Now you are reading B as the input symbol, A is the stack element, Q0 is the current state. Again you perform this operation. So you stay in the same state Q0. You have reached the end of the string. So B is what you are reading. So end of the string is epsilon and A is Z0. So you are popping that A according to this particular transition pop. So Q0 epsilon Z0. Now Q0 is reading epsilon and stack symbol is Z0. So epsilon Z0, what do? You just move to the final state Q1, keep the string epsilon as it is and Z0. You have reached the final state Q1. So this is accepted. This is accepted.